Okay, just wanted to show what happens when you put the high voltage DC without the capacitors on there. So we have a 15 kV 4 amp diode here. We got about 6,000 volts here, and just going right into our house power there through our kilowatt meter. So when I turn it on, okay, we're all the way up. Okay, there's nothing going on. Absolutely nothing. Throw some sand in there. Okay. All it's doing is just falling to the bottom. It's just sinking down to the bottom and falling down. So, you know, the power is there. Okay. It's jumping up to 200 watts. Okay. Going back down. Okay. So, without the capacitors, let me turn this off now. Without the capacitors, there is no effect. Now, in a book that I have, Westinghouse book. Actually, hold on, let me go get it. Alright, here we go. Alright, so here in Westinghouse Lighting Handbook from the 1950s, let's see, 1952, it's got cosmic rays in here. Bam. Cosmic rays. Okay. So, get to this part here. So, it says in here, light is that form of radiant energy which is capable of producing the sensation of sight. Visible energy is an exceedingly small portion of the electromagnetic spectrum, a tremendous range of radiant energy which travels through space in the form of electromagnetic waves. All of these radiations are similar in nature and in the speed at which they travel, the speed of light. They differ only in wavelength and frequency, and in the ways in which they manifest themselves. So they give a formula here that says the distance between crests of successive waves, shown here as L, okay, is a wavelength. Since wavelength times frequency equals velocity, which is constant, frequency is inversely proportional to wavelength. So what they're trying to teach us about frequency and wavelength here, but I want to focus on velocity. So a frequency over a wavelength creates a velocity. And now, of course, it goes on to talk about if you have a 60 cycle alternating current, okay, 31,000 miles long, that's a cosmic ray. Okay, so cosmic rays are at 60 cycles alternating current, 31,000 miles. Maybe we're using our grid system as a receiving antenna for these 60 hertz cosmic rays coming in, so that we can turn them into velocity and burn it in watts. So, okay, back over to here. Now, the capacitor, these are just basically, two giant aluminum antennas in here that are separated by a dielectric material. So the frequency, I believe, of the diode turning on and off, okay, to create the square wave, on, off, that frequency is creating, over the wavelength in this capacitor, is creating a velocity. And so it's a very high velocity, and when you so when I put them in these oil with the dielectric materials, there's a dynamic movement within the oil. Excuse me. So just by adding the frequency over wavelength, we're getting this velocity here, which what it may be doing. Okay, what it may be doing is the frequency over this wavelength is creating the velocity straight out of the vacuum through the Casimir force. The two plates really close together. The dielectric materials, they do hold charge. So I'm thinking that's the one way to explain how the Ampere's force law is creating not only a line integral with the electrostatic charge. When there's conducting material, it all stacks up and creates a electric field lines. When you put the dielectric material in there, it creates a convergence and a curl, very similar to the quaternion equations of Maxwell. Now, when you charge this for a second and you turn off the system, the force is still being generated between the two electrodes here for a period of I haven't done this one yet, time-wise, but usually it's a period of about an hour. And I've measured the voltage here, and the voltage doesn't go down when the dynamic movement in the dielectric stops. So that tells me that what's happening in the capacitor, the velocity is actually a demonstration of gravity, of the Earth's gravity. Through electrostatic excitation, the gravitational field can flow easier on smaller scales, and I think on all scales. So when you have this capacitance and this high electrostatic charge, you get the convergence and curl, which are the gravity. It's the convergence and curl, the torque and torsion of the space-time itself, which are made up of all the different electromagnetic fluxes. So no wonder it would, if you had it charged, it's like greasing the tube. When you grease the tubes here with the electrostatic charge, another force that is inherently convergent and curling and fractal. Okay, they just keep going. If you open up this vat, the counter-rotating vortices, they just keep linking up. and it's the most efficient way for that force to move. So this is related to Ampere's law force. The F12, Lorentz force that's between the two electrodes that attracts them. Well, there is that convergence and curl portion to it, which is related to the geometry of gravity. So, yeah, that's and what we can do is here we'll turn these on, and we'll get them started so that we can see the difference firsthand. Okay. Alright, so we'll put a little bit more of our glass in here just to kind of see if there's something going on. Alright. I'll just put my safety glasses on, turn it on, and there we go. A lot of movement now. Dynamic flow. Convergence and curl. Looks like I'm looking into a galaxy with all the... Oh, look, it just shifted. See, it like shifts from one side to the other. It'll spin around for a little while. So, definitely a difference when you add the capacitors. Okay? So, and here's the light, because it's a light equation. There's your light. Okay? So, and both of those capacitors are charged. I just don't want to do it with while I'm filming here, the back one. So there it is, the explanation and the demonstration of electrogravitation. Okay.